Awesome. Thanks, everyone. Before I get started, can we just get a round of applause for the CSEC team? When I was in uni, you guys have done a great job with this con. I know when I was in uni, I was a bloody potato. There is no way I could have run an event like this. So yeah, thanks for having me. It's awesome. Today I want to talk about hacking Active Directory, and I'm going to do it really fast. Basically, I want to keep doing attacks until I run out of time, or until you're all bored, basically. So obligatory, who am I? My name's Alexei. I'm Skorov, or Skorov8 on the Twitters. I like hacking Active Directory. I know Alex this morning said, what is even a real hacker? And like, yeah, there's no such thing. But when I hack Active Directory, I sort of kind of get that feeling like maybe I'm a real hacker. So it's always good. Co-founded Volcus with Matt over here. It's sort of something we do in our spare time all day, every day. I like climbing things. I like to ruin cars by putting big turbos on them. And I love dogs, especially that guy. That's Volk. That's my dog. He's awesome. So this is what we're going to be hacking today. And this is a lab environment of a bunch of Windows machines. We've got 3 domain controllers and 2 servers, and they are vulnerable to a bunch of stuff. I didn't make this. This is something that's made by a guy from Orange Cyber Defense. It's called Game of Active Directory. I've got it set up on my laptop here, and we're going to hack it. These are the attacks that we're going to do. We are not going to get through all these attacks today. There's a lot here. I'm just going to basically keep going. My goal with this talk is to just show you that these things exist. I don't expect you to learn that much today, honestly, except for where to go find the resources to go replicate the stuff that I do and also feel almost like a real hacker. There's a sort of complimentary or accompanying blog post to this talk. Feel free to scan that. It goes to our website with a bunch of references for how to get started and how to replicate a lot of these attacks, the tools that I use, everything like that. So let's stop babbling on. Let's start demos. Everyone knows that live demos always work, and this one will be no exception. Can everyone see that? Do you want me to make that bigger? Yeah, a bit bigger. All right, cool. So we're on the network. We don't know what we're doing yet. So we're going to use crackmap.exec and just quickly scan the network. See what we find. Oh, God, thank God it returned something. All right, cool. A bunch of machines. Winterfell, Marine, and King's Landing are domain controllers. You would normally sort of find that out in other ways. I'll let you explore how to do that, but I know that, and the rest are servers. So first attack we're going to do is called null session enumeration. We're going to attack Winterfell, and we're just going to ask it for a list of users. This doesn't work by default. This has to be either a misconfiguration or a vulnerability in this particular server. Cool, we've got a bunch of data out. We've got a list of usernames, which is a good start. And if we see here, these are account descriptions. We can see that Paul Samuel here has got his password in the description. That might seem silly, but we see that on pen tests too many times, like a lot of times. So that's a legit thing for you to check. That's, yeah, another vulnerability, password and description, number 2, cool. Next thing we're going to do is password spray. So using this list of usernames, we're going to try and guess what their password is. I'm going to use LDAP domain dump. I'm actually going to copy this and go U for user. This needs to be double. Password is Heartsbane, and we're going to go against Winterfell, run this against Winterfell as well. Okay, cool. That's done. Let's have a look. That's given us a bunch of information. So computers, groups, password, policies, other group policies, trusts, users. We just want the users. So let's go domain, users, grep, and we're just going to cut the 3rd column so that we have users That's it, just a list of users. Awesome. Going back to crackmap exec, we can do a password spray attack. Password spray is basically like almost like brute force, except we're rotating the password. Instead of rotating the password, we're rotating the username, either just the username or both the username and the password. So in this case, we're going to rotate the username and the password. So I'm giving that file to both the username field and the password field. So it's basically splitting that file into two and going bang, 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 trying those usernames as the password as well. I need to give this a server. We need to give the no brute force tag as well. Cool. All right, not many results, but we did get one. So we've got Hodor's password. Hodor. And that's a low privilege user account. So we haven't got much yet, but we're getting there, right? Now we've got an actual account to work with. At this point, I'm going to start another attack called name resolution poisoning. We're going to do this with Responder. So Responder will basically poison the LLMNR and NBTNS responses. You can think of those as broadcast DNS. So when a server goes, hey, who's got this name? And if that's you, what's your IP address? We just always go like, yeah, that's me, here's my IP address. The idea is to get machines to connect back to us. All right, I'll leave that running in the background. While we're doing that, we're going to do another thing called coerced authentication. This is a relatively new class of vulnerabilities. If you've heard of petit patam, that's part of that class of vulnerability. It's coerced authentication. So let's go ahead and try that one. Target, I'm going to hit Winterfell again. Our listener is this machine, so our hacker machine. I'm not going to give credentials yet, and this is going to basically show us that, yeah, it's vulnerable to coerced authentication without credentials. So something like petit patam. Awesome. We can see this machine account has connected back to us. That might not seem that interesting yet, but we'll see some attacks later on that we'll use for that. All right, while we're talking about that, we've poisoned this, which is a misspell of Bravos, right? And we've got Rob Stark's hash. We can go ahead and take this hash offline and try and crack the password offline on our beefy RTX 490s that are about this thick, if you've seen them. We'll keep that running though. We'll put a pin in that. We'll go back to the coerced auth, right? What happens if we try the same thing against a different server? So like Castle Black. Doesn't work, right? And this is sort of the default of what you'll see nowadays, is that you actually do need credentials to do a lot of these coerced authentication things, but any credentials. So you can do this with low privileges, like the ones we found, right? And now that we've given credentials, that has worked. We've actually got a connection back to us. Awesome. So let's go back to this. Let's say that, I'm not going to crack this live, but let's say that we did crack it live and it actually managed to get back the password. What can we do with that? Well, let's try and do a secrets dump. So we're going to log onto a machine as an admin. Well, we don't know if it's an admin yet, spoiler alert, whoops. And pull down the hashes and the secrets of that machine. So let's do that. Rob Stark, password, what do you think the password is? Sexy Wolfie. Let's do that against Winterfell, right? And awesome, that is working, cool. Don't worry about the exception at the end, we still have what we want. So we have a bunch of password hashes of the entire domain, basically. We don't even need to grab the clear text passwords of these. We can do another attack called pass the hash. So we can see, we're going to use crackmap exec again, and you know what, we're just going to try everything. So let's try doing this against all the servers. Cool, username of Edard stock and hash. We're going to do that. Need a tack. Cool. Let's see if this works. What have I done? 1. Thank you. Come on. So slow. Why so slow? What have we done? Okay, that's not good. Ah, we messed up. Live demos, huh? All right, awesome. So we're admin of one machine, but we still can log in other machines. Specifically Bravos, right, which is actually on another domain. We'll see in a second. But yeah, we can still log on with just the hash. That's past the hash, essentially. At this point, let's take a step back and try an attack called Kerberoasting. Kerberoasting is a bit of a weird one to explain really fast, but essentially there are users in the Active Directory world that are called service accounts. They're used to run services like MS SQL or ISS, like web servers, stuff like that. And within the Kerberos world, they have something called an SPN, Service Principal Name. What that basically means is, as a low-privilege user, we can pull the service ticket for that account, and that's basically an encrypted ticket. We can take that ticket and potentially take that offline to crack. So let's go ahead and do that. I'm going to go request. What have I done? What have I done? I don't know what I've done. Live demos, gotta love them. Cool, that's not good. What's happening? That is working. Oh no, I got that completely wrong. That's my bad. Let's go back. Okay. Reset, get user SPNs north.7 kingdoms. That's the domain. Helps when you write the right domain. Oh, thank God. Okay. All right, cool. So we've got 2 service accounts here, right? We've got one for Jon Snow. We all know that he knows nothing, so we're not even going to bother trying to crack that. But we have another one for SQL Service. So yeah, we would basically take this massive thing that's the encrypted TGS ticket and try and crack that offline to try and retrieve the password for this account. Let's say that we tried to do that and we couldn't crack it, so the password is actually quite strong. What else can we do? Well, we can just go ahead and dump the LSASS process. Think of this as like if you've ever seen Mimikatz in action, pretty much what Mimikatz does, but we're going to do this remotely. And we're going to do it with crackmap.exec, or a module inside crackmap.exec. Again, we're going to attack castle black. Hash, do I still have it? No, I don't. Let's just quickly copy. Oh God. Copy. Yeah, I missed a D. Okay. And we're going to use the module called lsasi. Okay, awesome. So we didn't get a clear text password, but we did get the actual hash for the SQL SVC account. Let's copy that hash and then, yeah, figure out where we can use it. To save some time, I'm just going to use it on Marine, which is the domain controller in another domain that's on our server. That's on in our lab, sorry. Cool. not an admin, but you see it as a valid account, and it's actually a valid account in that domain. So between the two domains that we have, we know that that password's reused across both domains. So now we've got a foothold in this secondary domain over here that we're trying to attack as well. So now's probably a good time to do another attack called machine account quota or machine account quota attack. There's a neat feature with Windows where anyone in the domain, by default with low privileges, can just create a new machine account. And a machine account is sort of like creating a trust relationship with the main domain controller over here. But for our purposes as attackers, as hackers, it's basically just a normal low privilege account. So if we can't get a foothold, we can relay a credential and make a machine account. We're not up to relaying yet. We will get there in a second. But yeah, we can sort of just do that. Let's see what that looks like. So local hashes, we're going to use, what are we going to use? Yeah, so let's use this one. Before that, we go SQL service, cool. Computer name. Let's just keep things really nice and muscle memory. Oh shit, that's my real password. Nah, just kidding. Okay, cool. We can see we've added a new machine account with the password that we've chosen. So we can use this for all sorts of attacks. And remember, as I'm going through these attacks, I sort of should have mentioned this at the start, but these are pieces of a large puzzle. You can mix and match anything that I'm showing here to achieve the purpose that you want. You don't sort of have to follow the set flow. The idea of this is all of these attacks can be put together or separate or mixed and matched to basically do what you want. So this could have been like the first or second step of our attack. Awesome. So with that done, how am I going for time? Going good for time. Awesome. With that done, let's do some relaying, some NTLM relaying, right? I'm going to try and do 3. Might not have time, but let's start with the most used. We're going to relay SMB to SMB. So we're going to receive an SMB connection to us, and we're going to relay that to another SMB server. To demo that, I'm going to use a tool that I wrote, shameless plug, called RID Relay. Pretty basic tool. All that it does is just dump a list of usernames, but yeah, through relaying. Cool. We can go. I need sudo python 3 RID relay. We're going to attack. Bravos. Okay, so that's set up. Listening, waiting for a connection, and we're going to go back to our coercer attack, except this time we're going to target Irene. Listener is going to be our server. Yeah, let's use the new account that we created. Why not? Okay, that's worked. And you can see we've got back a list of users. And again, if this was sort of the start of our attack path, we can just potentially do a password spray against these usernames. That was NTLM relay to SMB. Yeah, so you'll see, I kind of want to talk about this a little bit. You'll see that in a bunch of examples, SMB, you have to have an admin connect to you to get admin functionality on a server. And like, yeah, of course, to get code exec, you have to have an admin connect to you, and you need to forward that connection to a server that admin had rights to. But that's really sort of the start of it, right? Like, you can relay low privilege users to do all sorts of cool stuff like dump computers, dump usernames, get a password policy for the domain. You can basically do all of, like, not all, but most Bloodhound enumeration stuff just through relaying, if you can set that up without ever knowing a password. So yeah, don't think that if you don't have an admin, you can't do these attacks, or you can't do relay to SMB. The next thing is we're going to do an attack against Active Directory certificate services, specifically the ESC8 attack. ADCS is basically, yeah, like a thing that's used in Active Directory to be able to generate and sign certificates for that domain. We're going to combine that with another NTLM relay flavor. We're going to relay to HTTP this time, though. So we're going to use a tool called certipy, and we're going to try and find where this CA, or certificate authority, is. Find. We're going to use our account again, and we're going to do this against Mirin. So that's basically querying the domain controller and going, hey, do you have any CAs available? It's given us some output. Let's have a look at the output. What's in there? All right, awesome. So we've got output, and we can see that there is a server, and it's hosted on Bravos. Very good for us. We also want to search for domain controller. Okay, awesome. So it's got this particular template, and this template is it's a default template. It just exists when you set up ADCS, essentially. What this means is if we can relay a connection of a domain controller, we can create a certificate and get this server to sign that certificate for us. So then we can basically impersonate, we can impersonate that domain controller machine account, which, as we'll see in a sec, is a pretty big deal. So certipy, we're going to set up the relay, right? Relay. The CA is in Bravos, and the template that we want to use is domain controller. Yep, fair enough. Okay, that's set up. And again, we're going to sort of rely on our coercer to do this. What do I got here? This time, let's use the SQL SVC account. Hashes. Oh no, where did it go? Cool, not too far. So, yeah, normally, sometimes you need to do this weird thing. Okay, cool. So what happened was basically we connected to Mirin, which is a domain controller, coerced it to authenticate back to us, relayed that to Bravos, and said, hey, can you just generate a certificate for us? I'm the domain controller, I swear, just believe me, gen a cert for us. Okay, thanks, awesome. And it's made this file, mirin.pfx, which is our certificate, right? We can use that certificate to authenticate as that machine account. So finally, we basically go auth, give that PFX file. It will do Kerberos weirdness and basically give us the hash of that machine account. No clear text passwords, but the hash is good enough because, as always, we can do pass the hash. Last thing we can do is secret stump, as always. Okay, awesome. Now we've dumped all the hashes from SOS, our second domain. That's ADCS escalation of privileges and NTLM relay attack to HTTP. How am I going for time? Good. Yep, couple minutes. All right, cool. Maybe we'll get through all of it. Wow. All right, lastly, we're going to do, I'm not going to get through this, but lastly, let's do what's called an attack against role-based constrained delegation. That's a Kerberos thing. To explain Kerberos, I basically need another day. And even then, no one really knows how Kerberos works, right? It's one of those things that people say like, yeah, I know how Kerberos works, but they're liars. No one knows how it actually works. But basically, we can sort of, what we're going to do is we're going to go, oh, hey, this other server, can you just let me authenticate to you? But not just authenticate as me, I want to authenticate as anyone. And it's going to tell us, yeah, sure, no worries. But we need to set that up ahead of time for that to work. So for this one, we're going to relay to LDAP, right? But we're not going to do it from SMB. We're going to get a HTTP connection to us and then relay that to LDAP. We have to do that because SMB to LDAP does not work by default because of signing and other protections. But HTTP to LDAP works perfectly fine. And we can see which servers to attack by basically going and using crackmap exec with the webdav module. That's not what I wanted. No, should have kept it on there. Cool. Webdav. All right, awesome. What I'm about to show you can only be done on servers and hosts with this web client service enabled. Otherwise, it just doesn't work. There are ways to trigger this to open, which is a little bit outside of what I wanted to demo. You can certainly have a look at that if and when you try this yourself. But that's sort of a good way to check what we can coerce through HTTP. No, before we do that, let's set up our relay. Sudo relayx delegate access, and then escalate user. We're going to escalate the machine account that we created before, and the target will be LDAP Marine. So what's going to happen is we're going to connect to Bravos. We're going to say, hey, Bravos, connect back to us. Bravos will connect back to us using its machine account. We are going to relay that machine account to Marine, which is a domain controller. And because we have the privileges of Bravos, we're going to say, edit the machine account object and allow Volkus, $, that other machine account that we created, to authenticate to you as anyone. So let's go ahead and do that. For this one, we're going to do WH, which is webdav host. And we need to give the host name of our attacker machine here. There's a few quirks here, so ping me if you're doing this at home and it doesn't work for you. We can sort of step through it because there's a few quirks. Try and figure them out, but if you can't, yeah, hit me up. Oh my God. Why do I keep doing this? Yeah, we need to start this first. Okay, cool, that's started. Fantastic, so now Volkus can impersonate users on Bravos. Very good. Now we just need to get the service ticket. Again, this is Kerberos nonsense. This host Bravos part means we want full command exec over that host, basically. And who do we impersonate? Let's just administrator. Right. So we're going to be impersonating administrator on that server, even though we don't have access to that account at all. We can just do that now. Cool. Everything works? Yeah, good. Okay. Where was I? That should be good. Going well. Administrator. Thanks. That's why you paid the big bucks. Okay, now we've got our service ticket locally on our machine. It's in this file. Like that's the ticket that we have basically. To use it, we need to export it to a environment variable that is named this. Okay, and then back to our good old secrets dump, except now we use the K flag to say that we're going to authenticate using a local Kerberos ticket that we have. No pass and administrator. We need to give it the full, the FQDN, the fully qualified domain name here, because now we're in the realm of Kerberos, and Kerberos always works with FQDNs and host names and stuff like that. So, okay, awesome. Now, yeah, we're essentially administrator on that box, and we've got access to everything. That's essentially it. We went through 14 attacks today that you can do. I've chosen these 14 attacks because I feel like they're the most common that we see, and they're also the most impactful on internal networks. So we would do these attacks on internal pen tests pretty frequently. If you're a pen tester, certainly try them on your internals. If you're learning, yeah, set up the lab, give it a go yourselves. Check out the blog post, because it sort of gives you a starting point to work with if you want to do that. Otherwise, if not, if you just want to chat to me, I'm sort of here until 3. I'm here tomorrow. Hit me up. I have stickers. Happy to chat about AD. But that's all from me. Yeah, thanks.